So welcome everyone to Shumla's Lunch and Learn webinar series. My name is Dr. Karen Steelman, and I am the Science Director here at Shumla, Shumla Archaeological Research and Education Center. And we're so glad to have all of you here today. For those of you that don't know, our organization is a nonprofit dedicated to preserving and studying the rock art of the Lower Pecos Canyonlands, which is located in Southwest Texas. And we do that via documentation, research, stewardship, and education. And we're excited to have you here to present some of our new research that the team is doing. So for those of you who don't know me, I'm actually a chemist and not an archaeologist. And so as someone who uses analytical chemistry to answer archaeological questions, most of my research has focused on the chemical analysis of rock paintings. And there we go. The Lower Pecos Canyonlands is the ancestral home of many indigenous people. This includes groups whose names have been lost to time, colonization, displacement, migration, and settlement. And we acknowledge the ancestral peoples who created this painted landscape, along with the vibrant living cultures of the Colwatecans, the Apache, the Kiowa, the Tonkawa, the Comanche, and the Kickapoo. And we strive to honor both past and living indigenous people and their cultural heritage with our research. I'd also like to acknowledge that today is Juneteenth, which is a celebration of the ending of slavery in the US. And it's especially important as the holiday has its origins in Texas. So it's a big Texas thing. So just to orient us where we're located and where we're studying the rock art, the Lower Pecos Archaeological region is located along the Texas-Mexico border. And it's at the intersection of the Rio Grande, the Pecos, and the Devil's Rivers. We know of approximately 350 rock art sites on the US side of the border, with 35 known sites in Mexico. And if you've not been to this area of Southwest Texas and Northern Mexico has some of the most complex and compositionally intricate prehistoric rock art in the world. So for the last 2.5 years, we've been working on a project that we call the Hearthstone Project. And one of our main goals has been to build a chronological model for Pecos River Style pictographs. So we can begin to understand when the painting of these murals began, how long the style persisted, and then when this painting activity was ceased and ended and was replaced by different styles of painting that are also found in the region. Our team has finished the 2-year field and laboratory work, and we're now in year 3 of this project. We're busy writing journal articles so we can share these results formally with the scientific community. But you guys are getting a sneak peek today at some of our findings. So the Hearthstone Project is a collaboration between Shumla and Texas State University. Carolyn Boyd and Phil Daring of Texas State University are the principal investigators on the National Endowment for the Humanities grant. And then Carolyn and myself are the principal investigators on the National Science Foundation grant. And I've talked about this project quite a bit. So if you've attended one of these before, you've heard some of this before, but I know some of you may be new. And so we call the project the Hearthstone Project because it has 3 branches of study, which include formal art analysis, archaeological science, and indigenous knowledge. And so we make an analogy that to a tripod or in a Mesoamerican home, the griddle on the hearth or the comal where you make your tortillas has 3 legs of support. And so it's really, these 3 prongs of inquiry that we're using to learn as much as we can about the rock art. And it's really this interdisciplinary methodology and collaboration that is the way forward. So with the NSF, the National Science Foundation, the NSF portion of the project, we're focusing on pictograph stratigraphy and chronological modeling. So we're looking at the order in which the paint was applied to the wall, and then we're radiocarbon dating those different paint layers. From the NSF grant, we had funding for 60 paint dates from 10 different murals in the region. And so these are the sites that we studied. We've completed all of the work except at the last site at VV39. And those samples are in the lab, and we're currently processing them. Any radiocarbon dating project must be embedded in a robust documentation program. And so the Hearthstone project encompasses what we label level 2 and level 3 documentation and research at these select sites, at these 10 sites. And our research design involves selecting central figures with identifiable attributes that are repeated across the landscape. We're going to conduct, we have conducted a formal art analysis by documenting, describing, photographing, and illustrating those selected figures for dating. And I use this example a lot because it's just so beautiful. But this anthropomorph or human-like figure has wrist decorations, holding a finger-looped atlatl, black atlatl and dart with fletching. It's got a stylized tip with red shape that we call a single pole ladder. Let me see if I can get the laser pointer to work here. So it's what we call a single pole ladder shape. It's also here on the sides of the body. This figure is just beautiful. It's got like this black wrist adornment and the rest red wrist adornment. It's got extra darts and this really decorated staff. And then this shape coming off of the staff that we see over and over again. And it's got this hatched line along the body with these single pole ladder shapes. Just a really, really beautiful figure. So I'm showing you a false color image. It's enhanced using an application called D-Stretch, which most of you are familiar with. And it can be used on the computer or in the field on a mobile phone. Most notably, this figure has red deer antlers with black dots on the end of the tines. My collaborator, Carolyn Boyd, has interpreted these attributes as being related to peyotism, which is a sacred hallucinogenic cactus associated with creation and renewal by Native American groups. And so, what the team is doing is we're conducting a formal art analysis. We're interested in this figure with the deer antlers and the black dots. And then we're going to document, describe, photograph, and illustrate that figure. And so we're going to select certain figures across a panel to do that. So that figure that I showed you is just one of hundreds of painted figures at a site called Halo Shelter, shown in this amazing rendering, also done by Carolyn. And as part of our field work, we went and conducted digital microscopy across this entire panel at this site. And we also obtained 13 radiocarbon dates for pictographs at Halo Shelter. So from the microscopy data that we have from the site and putting that data into Harris matrix, and I'm explaining some of this a little bit in more detail as we go along, but from doing that microscopy and looking at the order that the paint was applied to the wall, we were able to determine that all of these figures are interwoven. And by that, I mean that this panel was painted by color and not by figure. So, and it's what Carolyn had seen for the White Shaman site, but now we're seeing that this color order is happening at other sites in the region as well. So all the black paint was painted first, then the red, then the yellow, and then the white. It's absolutely astounding. And this is a planned composition. So how our team determines all of this is first by conducting digital field microscopy using a Dynalite. Dynalite is the brand name of the little handheld microscope that we're using. And we use that to understand the paint layering of that central figure with other figures in the panel. So we look at superimpositioning. So here you can see that the red is painted over the black. And so our research plan was to radiocarbon date paint samples from that central figure of interest. So like the figure with the deer antlers, But then from the stratigraphic analysis, we also radiocarbon dated paint with figures that were in association with that figure that were interwoven. So we radiocarbon date from the first applied bottom paint layer and then from the last applied top paint layer. So my example here is simplified with only 3 polychrome figures, but at most sites, we often have 30 or more figures that are in superimposition with each other. So to keep all of that data straight, our archaeology team uses a computer program software called Harris Matrix Composer to build these flowcharts or these Harris matrices. And this data helps us select the best locations to collect samples for dating. And because we're wanting to maximize the amount of information we obtain with just dating a few samples. So when we date that central figure of interest with the attributes that we're studying, and then we date paint from that first applied bottom layer and then from the last applied top paint layer. I know I said that a couple times, but just to kind of put that in perspective. So what would the results look like? Well, so we sort of hypothesized, well, if the mural is a composition painted all at the same time, we should get statistically indistinguishable ages. They should all be the same age. But if portions of the mural were painted at different times, it's going to tell us sort of the chronology of the painting sequence at the site. And so either way that this came out, we were going to be really, really excited about it. And it turned out, though, that we're seeing that a lot of these murals are compositions that were all painted at the same time. So let's look at some of that. Oh, the final product of the project, this is really important, was an illustration of the panels. And Carolyn and Phil have taken copies of these panels to different indigenous groups in Mexico to seek their consultation and wisdom for interpretation research. And so stay tuned for next month's Lunch and Learn, because Carolyn will be presenting about this next month. So be sure to sign up for that. Okay, so this talk is supposed to be about radiocarbon dating pictographs. So I have to throw in some chemistry. And so how do we do that? Well, we use 2 different methods. So here we're looking at a cross section of paint, a paint chip that's turned on its side. And with the first method that we use to date the rock art, we extract organic material from, in this example, the black paint layer, using a technique called plasma oxidation, followed by AMS measurement to obtain a direct date for the painting. But we also have a second method that we use to date the rock art, and we do that by obtaining indirect ages by radiocarbon dating the calcium oxalate, the mineral accretions that are overlying and underlying the paint layers. So that's in this sort of cream colored that's marked in yellow below, and then this porous area, grayish area down here below that's marked out in green. And this will give us minimum and maximum ages for the paintings. So it's kind of like a sandwich, an Oreo sandwich. You're gonna date the 2 pieces of bread, or Oreo, the 2 chocolate pieces, and then the paint is the cream filling. So here's the plasma oxidation instrument that's at my laboratory at Shumla. And this was constructed with support from a previous NSF grant. And this first method that we're using this with is directly dating the organic binders and vehicles in the paint layer. And to do this, we use this technique called plasma oxidation. And this is a method that was specifically developed for dating pictographs by Marvin Rowe. Oxygen plasmas are ignited with an RF generator, and this electrically excited oxygen, you can see it glowing in the photo, is sufficiently reactive. It reacts with the organic material in the sample, but the temperatures that the sample experiences are below the decomposition temperature of any carbon-containing minerals such as limestone and hewellite. So the plasma oxidation is a way to just pull out or extract that organic material as carbon dioxide, but then we leave everything else as a solid. So the sample goes in this tube. You turn on the electricity, the organic material turns to carbon dioxide, and it gets frozen in this tube that is immersed in liquid nitrogen. And then all the rest of the sample just sits here as a solid in the tube. So what we're interested in is this carbon dioxide that came from the organic material the binders and vehicles in the paint sample. Once we have that carbon dioxide, it gets radiocarbon dated using a technique called accelerator mass spectrometry. I work with Lawrence Livermore National Laboratory in California, and they do that measurement, and we can calculate an age. So let's look at some results. So here are the 13 direct radiocarbon dates on organics in the paint samples from Halo Shelter. And they're beautiful. They're all statistically agreed. They're all statistically indistinguishable from each other. And from the microscopy and the Harris matrices data, we know that we can average all of these dates. So these are not individual samples from different paintings. They're subsamples from the same painting. And so I want to kind of talk about that for a minute. If you had a canvas painting that was in a museum, and you had a building and a tree and a person, and it was arranged in a composition, you would assume that all of those are the same age. And so for rock art, we've got to get in the practice of, if we can show that we've got a composition that, you know, if I take from one figure and I take from another figure, those are not two separate samples or two different paintings. They're two samples from the same painting. So they're subsamples from one painting episode. And so what's cool about that is, because we've shown through the microscopy that the panel was all painted at the same time, then we know we can average all 13 of these radiocarbon dates. And that's important, because by averaging them, it gives us a smaller, tighter age range. An average is always better than any single measurement. And so the weighted average at Halo shows us that it was painted sometime between 45 BC and 65 AD. So that's pretty cool to know the age of that mural. Now, the second method we use in my laboratory for dating pictographs provides minimum and maximum ages. So we're looking at that overlying and underlying mineral accretion that is associated with the paint layers. And these often contain a mineral called calcium oxalate, and that's this chemical formula here, C2O4. So it's got carbon in it, and we can radiocarbon date that carbon that's in that mineral accretion. Now, there are several steps in the process of these accretion steps to process them for dating. I'll list them, but don't get too fixed up, because I don't have it written out. But first you have to dissect the paint flake under a stereoscope and get those individual layers. And once you've put those aside and you've done that dissection, we do infrared spectroscopy to confirm that there's actually oxalate present, which is what you see in the picture on the right. And then we wash that powder in phosphoric acid to remove any carbonates. We do additional IR spectroscopy to show that we got rid of the carbonates and the oxalate is still remaining. Then it goes into the plasma, and we clean any organic contamination that might be on the sample. And we're left with this purified calcium oxalate solid residue, which gets burned up or combusted into carbon dioxide, turned into graphite, and then there's the AMS measurement. See, I told you there was a lot there. But anyways, the point is we can date that mineral accretion. So let's look at some results for that. So this is data from Jackrabbit Shelter. So using plasma oxidation AMS, and this is actually what I'm showing you right now are the first method, the organic dates. So this is radiocarbon dates on the binders and vehicles that are in that paint layer. And we have 5 direct dates for 5 different figures in the composition. And you can see that they all line up. I've turned this graph sideways, so the age is actually here on the y-axis, and it's just because there's so many numbers there, it just looks better this way. And then the red line is the weighted average of all of those measurements. But the team has also done the microscopy data and the Harris matrix and looking at the superimposition of this site, and it indicates that this site is a composition as well. And so, again, these dates are remarkably consistent at about 2800 BC Or another unit that we use is 4,700 Cal BP. Cal BP means like years ago, so 4,700 years old. So that's pretty cool. But then let's look at that oxalate data. So at Jackrabbit, we also use that second method of dating the oxalate mineral accretions, both overlying and underlying the paint layers, to obtain indirect maximum and minimum dates for the paintings. The overlying accretions are younger, and the overlying accretions are younger, and the underlying oxalates are older. So like look here at paint sample 1, the direct date is in the middle, the outer accretion date is younger, and then the underneath accretion date is older underneath that line. So the same for sample 2, 3, and 5, but sample 4 only has an overlying date. We weren't able to get that underneath date on that one, but this data is just really beautiful. These oxalate dates support the direct dating of the pictographs, and it's the most, what you're looking at right now, I believe is the most comprehensive dating of pictographs anywhere in the world, where we have 2 different methods that are supporting each other. And that oxalate dating gives us confidence that those direct dates are correct. So I also want to show you the dating results from Jaguar Shelter. These are the oldest ages we have for Pecos River Style pictographs so far, at about 3,500 BC or 5,400 Cal BP or 5,400 years ago. We have 6 direct dates at the site, but we also have 4 oxalate dates that are over and under that are supporting this data. So this is really exciting. So now what I want to do is transition and talk about some work that I presented at Aurora in May on Eagle Cave. Now our team has been working at Eagle Cave for quite a while, but we just recently got 3 new radiocarbon dates from the site. Its site is near Langtree, just off the Rio Grande. To give you an idea of scale, Eagle Cave is about 200 feet wide and about 50 feet tall. And it was excavated in 1932 by E.B. Sales and Charles Kelly. And then in 1935 and 36, the Whitty Museum also dug a large trench through the center of the site. In the 60s, the University of Texas expanded that trench. But what you're seeing here in this photo is more recent excavations from 2014 to 2017. A team from Texas State University led by Dr. Steve Black and Dr. Charles Koenig have conducted excavations, and they have an excellent blog post. So that's what's up at the top of the slide. If you've never looked at that, it's just wonderful, chronicling all of their work at the site. It's called the Ancient Southwest Texas Project. But what's important about this is because there have been excavations at this site, we're going to be able to tie the results that we're getting from the rock art to the archaeological deposits. And so that's something that has very rarely been done. So on the back wall of Eagle Cave, there's crystal formation that's causing deterioration of the wall surface. And so we wanted to understand this geological process because it can affect the preservation of the rock paintings. And so as we zoom in, we observe that these crystals have these interesting striations, and it shows that they're composed of gypsum and calcium oxalate. And what was really cool about that is we were able to date those oxalate accretions and show that the oldest age that we got of about 6,300 years old, so 6,340 years BP, it shows that the rock wall surface has been stable for the past 6,000 to 7,000 years. But then after that, you get this, the wall starting to deteriorate. And so that wall is only 6,000 or 7,000 years old. So that would be a minimum age for the paintings. I mean, a maximum age, get it right, maximum age for the paintings, right? So if the wall is only 6,000 to 7,000 years old, the paintings can't be any older than that. But it's a minimum age for that wall, like that the wall is 6,000 to 7,000 years old. So it's really interesting that we're able to look at dating the sort of stability of the shelter wall. So the preserved rock art panel at the site is on the downstream end of the shelter. And this is on the computer here. The team has taken a de-stretched, enhanced version of a gigapan image. A gigapan is where we've taken like hundreds of photos and then stitched them together into sort of a map of the site, so you can look at all the figures at once. And on the computer, we have circled all of the locations with intersecting paint color that's associated with the figures that we're interested in for dating. And so these are all of our target locations for doing that microscopy. So we actually take a printout of this into the field with us, and that gives us a map for where we want to hold that microscope and look for those paint layering. So here's the team doing the digital microscopy and looking at all of those intersecting paint color locations to determine the order that the paint was applied to the wall. So look at those two photos there and come to your own conclusions. But on the top right, okay, you got it, your answer in your head. So it's the yellow over the red. You can see here that the yellow is on top of the red. And then in this bottom one, you got your conclusion in your head. You can see that the red is over the black. And it does take some practice to look at these, but these are pretty clear. What we do is we have 3 team members look at that data independently before we make a final determination. And all 3 have to agree for us to accept that data. This is a map on the computer on the GigaPan showing all of the locations where the team did the digital microscopy. So it's documenting what we're doing. And then all of that sort of data from the photographs, that yellow over red, the red over black, etc., that goes into this Harris Matrix Composer software to create this flow chart, which then we've color coded to show the paint stratigraphy. So let's look at some more pictures of Eagle Cave. This is this about 5 foot tall rabbit ear anthropomorph that has speech breath coming out of its mouth. We took, for radiocarbon dating, we collected a sample of black from the torso and also yellow from the torso. And then here, this is just this figure up close because it's so beautiful. But you can see it's got a black rabbit ear outlined in red and a yellow rabbit ear, looks like outlined in white. But for easier visualization, I'm going to show you an illustration. And so here, this isn't the whole panel, but it's a good portion of it. And so you've got, one of the things I want to point out, and see if I can get my laser pointer to so we're interested in this figure with the rabbit ear, the yellow and black. So we've got that, but then you have this red line, and my pointer's not going to work, but you have a red line that goes through that. And so you can see that the red line is over the black, but it's under the yellow. And it's really cool. It kind of gives it almost a 3-dimensional quality to the figure. So we also radiocarbon dated that line because it goes all the way across the panel and intersects with this other figure, A13. And then it's not, let's see if I can do it. Yeah, so it's not colored in, but this is a part of this figure here, this A13. And then that's intersecting with these black figures that are in the row. And so we also radiocarbon dated this figure here, A7. So, we've dated this line, we've dated this winged figure, this figure, and then this big, large figure that we're interested in with the rabbit ears, because we're looking at the way that the color is intersecting with each other. On sort of far panel right, there's also this figure with the addle and the dart also holding the staff. And then we also dated this other rabbit ear figure that's on panel right. So let's look at what those dates are. And the 3 new dates that we have are right here at the bottom. We had already had some of this other data, but this is brand new data right here, these 3 dates, and they line up with what we already had. So all of this in blue is for the paint dates. And then we have the underlying oxalate and we have the overlying oxalate that is younger. And so again, this shows that this site is a composition, and we're able to radiocarbon date the paint, and we're able to calculate an average for this site. And so that average here shows that, you know, the paintings are correspond to about 1690 to 1440 BC. So it's really this combination of microscopy and radiocarbon dating that's this interdisciplinary research that we're wanting to do, continue to do in the Lower Pecos, that we've sort of come up with this methodology as part of the Hearthstone Project. Just to show you a few more things. So looking at all the new dates that we've obtained for the Lower Pecos during the Hearthstone Project is the data that you're looking at right now. And it's interesting because we have continual production throughout the middle to late Archaic. So the oldest ages at Jaguar Shelter are at 5,400 years ago, and the youngest ages are at about 1,400 years ago. And this is just simply remarkable that Pecos River Style painting persisted for at least 4,000 years. Just about 6 months ago, we got results back from Raymond Shelter and Camey's Corner, and I point these out because before we had these results, there was a gap of about 1,000 years, and we didn't know if that gap was real or if it was sampling bias, being data only from 10 sites out of 350 sites in the region. But we were careful to select sites based on geographical and iconographic diversity. So it's really interesting to see the spread in all of these dates. And so what we're doing now is we're going back and we're doing that iconographic inventory at these sites and saying, okay, which of these sites has, say, the single pole ladder motif? Which site has the rabbit ear motif? Which site has the deer antler motif? And we're starting to tease out and see, in sort of our preliminary data is showing that these things persisted across the majority of the time span. And we didn't know that. We didn't know if certain motifs would be more chronologically specific. So what we're seeing is the most complete picture of Pecos River Style pictograph chronology we've ever had. And combined in this graph are 42 direct paint dates and 20 oxalate dates. We still have one more site that we're waiting on radiocarbon dates for, so processing those right now. But it is interesting that those dates at Camey's Corner and Raymond Shelter are statistically indistinguishable, because both of these sites, the illustration on the left is from, I believe that's from Raymond Shelter, is this winged figure with antlers, and it's present at both sites. This is very similar to the figure that's also in the state park at Fate Bell. So again, our research questions are more specific than just how old in general is the art. We knew from legacy data that Pecos River Style was somewhere between 1,000 to 4,000 years old, though now we've shifted that another 1,000 years back in time. But we wanted to be able to ask questions such as, how old are deer headdress figures, and how does that compare to rabbit ear headdresses? Are they all from the same time period? How long were they painted? And we're just really sorting through all that data right now. But we are able to get at that data now, and we hadn't been able to before. So we're very, very excited. I'm very excited to show some of this to you. I want to thank my team, my collaborators, Dr. Deanna Rodillo-Rolón, Dr. Phil Daring, and Dr. Carolyn Boyd. The work we do is interdisciplinary, and we're only able to accomplish our goals because we work together. I also want to thank the entire staff of Shumla. It's a wonderful team that works on the documentation and the illustrations. David, Katie, intern Naomi, Deanna and Siobhan. Audrey and Tim and Ashley are folks that have been working on this project in the past. I especially want to thank Rudy Bainey, who helped me with a lot of the laboratory work, though here he is in the field. And I want to thank also Shumla's executive director, Jessica Hamlin, who enthusiastically works day in and day out to support this research. This project was partially funded by the NSF and the NEH, but there were also many private foundations and private donors who support this work. If you would like to support this research and programming, please consider, making a donation. And I thank you for your attention. I'm gonna stop sharing so I can see all of you. And did anybody put a question in? There was no questions in the chat.
No, but I have one.
Yes, Harry, where are you?
I know where I am, but I never know where I am. But Karen, I just want to tell you what a fantastic data set you all are building. It really gets tears in my eyes when I think about the string that started in 1988 and where you are today.
Oh, absolutely. I mean, for me, I sort of came in about 2000 and started working on this, but and when I did my PhD work, I knew about the work in the Lower Pecos, but I actually didn't work in the Lower Pecos. For my dissertation, I worked on, some other things. And, it's just an area that I'm drawn to, and just really fantastic to see the progress that we're able to make. And it's because we work together as a team. If I was just a chemist doing my thing without, working with Carolyn and Deanna and all of our team, I wouldn't know what questions to ask, or I wouldn't maybe pick the right samples and stuff that would give the information that they're after. And so it's really that combination, I think, that makes it able to make so much progress.
Absolutely agree with you. And what I want to see, like at Eagle Cave, I have in my mind where those dates fit in terms of the chronological scheme. But that in itself is an amazing book to tie in those dates to the cultural chronology, because we've been doing it intuitively, since Marvin started the dating. But you guys you're right. It's an incredibly world-class team. There's no question about that. But you all have got some tremendous data there that can just build so much more on what we know about the archaeology of Lower Pecos. So I just want to congratulate you.
Oh, thanks, Harry.
I second that. This is Kay Killen now, Wilson. I have to say, I'm just blown away by your research and by your presentation. And I've been going to Seminole Canyon since before the park opened, and had the good fortune to go with my compatriots out to many of those sites. And as I say, you've come a long way, baby. It's just so phenomenal to have you there doing all of this. And I may have missed it, but did you address, the radiocarbon and the we had nothing back then, to really compare to what you're doing now, and the comparison is just phenomenal. And as a leader of the education committee for the Council of Texas Archaeologists, I know for a fact all the rules and requirements and educational designations need to be updated, because back then when we developed some of that, none of this was on the books. And I applaud you. Thank you.
Yeah, thank you.
Aaron, this is Mike Mills from McAllen.
Yes.
The Jaguar shelter, that's with the big Jaguar painting?
Jaguar is there is a figure that has spots on it at that site, which is why it has that name.
That's different from the famous Jaguar painting.
Yeah, I don't think it's the one you're thinking of.
I'm just amazed that so many of these are so old. 3000 BC.
They're old.
4000
Yeah.
BC. It's just amazing to me.
Yeah.
Sophisticated that far back.
Well, and the wall is only 6,000 or 7,000 years old. I think there were paintings before then, but
It's
they
just amazing.
curated, and it's just
It is
I absolutely
amazing.
agree. Yeah, I absolutely agree.
It's amazing, amazing.
so. And then I get excited about the younger dates too, because it shows that there's a persistence of the rock art, and so. You know, a lot of people that do dating work get really excited about old ages, but and sometimes I get excited about some of these younger ones too. There are some questions in the chat, so I'm gonna go look at those really quick. So let's see. Brian asked, are all the sites sampled so far single compositions? And the answer is yes. We still have about 2 or 3 of those that we haven't finished all the analysis for, but the ones that we have done the analysis for, we're seeing this sort of interweaving of paint, which is something we weren't sure about. We didn't necessarily know that all sites were like that. You know, I'm talking specifically about Pecos River Style. Okay, Kelly says, I see the Black Cave Annex date. How difficult is it to get samples in the state park? Any possibility of getting a Fate Bell date? Yeah, so we have worked with TPWD on a couple of places where we see a flake that's like hanging there and we know it's going to be lost in, you know, the next, you know, it could be the next year, it could be 20 years from now, but it's loose and you know, it's a flake that is exfoliating from the wall. And the park has allowed us to take some of those samples for dating, but you know, it is becoming more and more difficult when you're working with government agencies to do that kind of thing. So you know, we're not planning on trying to date Fate Bell anytime soon just because of that. One of the things I would like to do is like maybe on not Fate Bell because it's so visited, but on some of the sites that aren't, is like, what if we put a tarp down and like collected things that fell? But then the question is knowing which figure it came from, because we need that iconographic information to tie that to real information. You know, we're not just dating the site per se, but wanting to know which, you know, that figure. So something to think about. Dan asked, do you have any evidence for individual figures being painted at wildly different dates in the same shelter? Seems from your work that each shelter was started and finished within a short defined time period. And that does seem the case so far for these sites that we've looked at, that we are not seeing, we're seeing all the dates cluster at a single site. And then the microscopy data is showing this sort of interweaving of colors. You know, every once in a while you'll get like maybe 1% or something of the paint that's not in that particular order, but almost all of it is. And so most of these figures were painted all at the same time. Yes, Annika.
And I'm not being an artist, and I don't really know how or why it's done, but why paint at black first or red? Why do it in this order? Is it the difficulty in acquiring enough paint, or is that what artists do, or why?
I think there's several reasons, and I think they all tie together. I think that some of it, if you think about the pigment being very valuable and mixing up that pigment, trying to, you know, you've processed it, you've done lots of, you know, maybe you ground it up, maybe you density separated it to get the really fine powder. You've made a paint cake, you got it from, you know, 100 miles over there, you know, all of these things. So it's very valuable. So not wasting it.
Right.
But also, I think there's a lot of artists will talk about painting from dark to light, and that there's some artistic reasons to do that. But then in the ethnography that Carolyn has looked at, there is, you know, because this is basically religious painting. This is part of your culture. There are cultural reasons for doing it that way as well. That not, we think oftentimes of the practical, but there's also that this is, we're human and we don't always do things that are practical. And so it's, you know, she's talked, I'm just repeating what Carolyn is taught me is my collaborator, but things like they look at it as far as like the rising of the sun. So at first it was dark, so black. And then as the sun rises, the sky is red. And then as the sun rises further, the sun is yellow. And then in the midday, late afternoon, you have like that white, bright light. And so that there is this progression that has to do with the I don't want to use the word myth, but your belief system. And so there's a reason for
Well,
that.
there's obviously a reason, or maybe several reasons, but I was
Yeah.
just curious. Yeah.
Carolyn, do you want to add anything, or are you good?
No, you did really well. That's what we were told by the Huichol when we were there with them last year, and I'll be talking a little bit more about that when I present next month.
Let's see, we have another question from the chat. Do symbols or iconography persist through the entire 4,000-year span of Lower Pecos rock art? Yes. And I'm not going to remember all of them because we're starting to put them out in charts, and like we have the dates and then we put the symbols and we put it by each of the dates, and we're starting to look at all the iconography at each site. I know there are certain symbols. I believe the single pole ladder motif goes across the whole span. I believe that sort of power bundle shape goes across the whole span. That's coming off of one of the arms of the figures. There are some figures that may not be across the whole span, but we're not sure yet. And so I'm not quite ready to say that, but we have some theories about some of this and how it might be changing. I mean, I think it'd be really interesting for a student to look at paint application methods and how they date. Do they go across the same span? So there's a lot of like data that we have that could turn into lots of different research analysis of that data. But yes, we do have some sort of old symbols that seem to persist for a long time. Anson asked, is there any publicly accessible database that shows sites, figures, and dates? There's not a publicly accessible database. There's a lot of information on Texas Beyond History, which is a website that has a lot of, it's an educational kind of type website. And then if you're familiar with Kirkland's book that has all the watercolors in it, that's a really good place to see as much information. Right now, the dates are, a lot of the data I showed you hasn't been published yet. It's brand new data. And so as that comes out, we should have some publications that will have all of those dates in one place. And hopefully we can make some of that open accessible so that it's not just, behind a paywall of some fancy academic journal, but can actually be, seen by everyone. But we're not there yet, but we'll get there. There was oh, Lori's here. Hi, Lori White, wherever you are. And then let's see. Oh, there's some more. Can any cave surface be dated? So the question was, can any cave surface be dated? And the answer would be no. So it has to do with which minerals are present and what's the geology of the site. So what we're doing with radiocarbon dating is looking at a mineral called calcium oxalate, and it occurs almost everywhere I know limestone is. So it works really well on limestone. And oxalate has been seen on some sandstone surfaces. So there is potential when you have sandstone, but I've never seen it on granite. But I don't know, that's, something that would be interesting. And I'm talking about radiocarbon dating. There are some, thermoluminescent or optically stimulated luminescence and things like that sometimes do surface dating for light exposure and things like that, things that have been buried versus things that have not. But that's sort of also very specific. There's another question here. Y'all are all hanging in with me. So is there any way to determine the duration required to complete one of the paintings? And can you tell by their techniques that there was more than one artist involved in the works? So we have a fine artist named Ashley Busby that's working with us. And she's looked at some of this, looked at paint application. Carolyn herself is an artist, and so she's looked at some of this as well. And I'm not an artist. I'll have a confession for y'all. My only C in college was in freehand drawing. There are certain paintings that and I trust the artists because they're very methodical in the way that they look at things, that they think that certain things are done by the same hand. I've heard other artists talk about how they think maybe there was a head artist, like a master, and maybe there were some apprentices that were helping to paint. So I don't think it was like 20 people trying to paint this thing. I think it was, maybe 2 or 3 people, but this is me sort of hypothesizing. I don't know how you would prove that. But I can say that with the techniques, they're using lots of different techniques. They're using like Jackson Pollock, where you like load your brush and you flick the paint at the wall. They're using brushes, they're using hands, they're using stencils, most likely. So there's a lot of different techniques that are being used.
Karen, this is Jackie.
Yes, Jackie.
It looks to me like you were a pioneer in this technology. Are other researchers following your procedures and techniques?
So we would like to see that. This technique that we're using, called plasma oxidation, it was developed by my PhD advisor, Marvin Rowe. And then I was one of his students. One of his other students does have some of the equipment and does do some research. Her name is Ruth Ann Armitage. But there's not a lot of people that are trained in this. And so that's something, we have interns that come and we'd eventually like, to be training, graduate students with this kind of technology. Because it seems to be the best way to date rock art. And I'm not saying that because I do it. I'm saying it because I really believe that. I wouldn't be doing it if I didn't think it was the best way to do it. And so there are some other methods to date rock art, and they're valid, but dating rock art is a challenge. We weren't able to date rock art until really some of this technology was developed. And so it's something that we really, I'm concerned about, because I really want to see the field keep moving forward.
Well, your results are just fantastic. Absolutely fantastic.
Yeah, thank you.
Oh, I was wondering about damage to the rock art when you're dating it. Do you have to worry about that at all?
You do a little bit, and I love these paintings so much. And so I'm very, very careful. I come from kind of a conservation background. And so one of the things that we do is, it's why it's so important to do all of this documentation first before we do dating. But our sample sizes, we've been able to reduce the sample size needed for dating such that it is so small. It is about the size of about half of a dime. And so if I can, sometimes I get more material because the site is already falling apart. Unfortunately, with most rock art around the world, it is in poor condition. There's a lot of preservation issues already there. And so we are not taking anything that wouldn't already be lost by natural exfoliation and natural degradation. And so, we want to get some information because we're going to lose it anyways. And so we want to try to get information from those samples. But it is something that is I'm very sensitive about.
So can you go back in and kind of repair the area?
We haven't. We document what we do. We take extensive before and after photos. But when I've gone to a site like a year later, I can't even tell where I took this sample from most of the time. And I've had, other people who weren't with me when we sampled say, okay, where do you think I took the sample? And they'd point out something and I'd be like, or if I have my notes, and so I know where it came from, and I'd be like, nope, that's not where it was. And so there's so much already natural destruction happening to these sites that what we're doing is very minimal compared to that. But we are documenting these sites to a level that, if you wanted to, we have like digital 3D models of the sites before we go in and do this. And so, we're more worried about a flood or a natural disaster or something, destroying these sites than we are the things that we're doing.
Sure, sure. Thank you.
Mm-hmm.
Karen.
Yes.
Geographically, are the Boca and the Jaguar shelters close together?
Yes, they are. Boca is just my name because it's at the mouth of the canyon.
Another question, is there any indication, I think there is, but is there any indication that some of the red linear sites and paintings are a little earlier than any of the Pecos River style?
Yeah, so what Jim is asking about is another style of art in the area called the red linear, which are these sort of miniature, almost stick-like figures. And the team has found that Carolyn and Amanda and Charles worked on a project where they looked and they always saw these underneath Pecos River style. And then I worked with Jared Roberts on his master's thesis research where he documented some of them, and we did radiocarbon date some of those red linear figures. And the dates, I don't remember the numbers, but they are older than or contemporary with Pecos River style. So it matched what they were seeing with the stratigraphy. But what we did with Jared's thesis is we dated red linear that was by itself. And what we need to do next as a next step is look at sites that have Pecos River style and superimposition with red linear. And then look at that dating, I think. But to see how far apart they are from each other. Because they're underneath, but we don't know if that's 2 days or 1,000 years. And so that I think that's the next step. But yes, from the preliminary data that we got with Jared's research, it shows that they are sort of that older, a little bit older.
Have y'all sampled Mystic?
No.
That's one would be, as Carolyn knows, would be a good candidate for that.
Yes, I agree. There's some other questions in the chat really quick. Here we go. Marilyn asked, are there any other researchers around the world doing the kind of research that Shumla does? And we sort of touched on that with Jackie's question with the chemistry stuff. But I will say that like that little digital microscope and stuff that Carolyn has been doing with the rock art, that has become almost a standard tool now for a lot of rock art researchers around the world. But the reason I work at Shumla and the reason I work with Carolyn as my collaborator is that I don't see the level of detail. A lot of people are looking at like one figure over another, but they're not looking at like each color in the figure. And so I think, because I want to know, is there anywhere else in the world that they do this kind of color stuff? And I haven't seen that yet. I haven't seen that. And so one of the things that I really want is us to get the word out, because I think what we're doing is really great. And I want other people to be doing it too. And there are some amazing research, a lot of people that I know that's one of the things that's really cool about what I do is because I date rock art, I work in Texas, but I also work with some archaeologists in other regions, and I get to see the cool techniques and methods that they're doing as well. So let's see. And then Harry wrote, the very first paintings that Marvin did came from VV75. Yeah, and so you
Yeah,
know,
I want to mention that because those were exfoliated pieces. We picked those up off the
right.
shelter. So but that site is it's Seminole Canyon. It is one that's been dated to Seminole Canyon, but it's very early one. But that's deterioration on that wall is pretty bad, as you know.
Yeah, and some of those were pretty big exfoliations that, you know, that were coming off naturally. So absolutely. And then Kelly's commented that she'd love to see the winged figures at Fatebell dated to compare to Raymond's. That would be interesting, wouldn't it? And then let's see, here we go. If these are, Deborah asks, if these are related to the religious aspect of their life, isn't it likely there would only be the shaman and perhaps one person being trained as the next shaman doing the paintings? It would seem it would be protected knowledge as being sacred to the people. Is that off base? I think it's, you know, I think there are, you know, indigenous societies or levels of knowledge. But I think also these are master artists. These are people that are really skilled. And so I think that you would have to be trained to do this. You know, I do think that it's probably just a few people. So Anne says, I'm thinking about how these pictographic images persist over several thousand years and wondering about whether mostly not images in their own culture and our own culture persist. It's a fun thought experiment. Absolutely. Like, for example, like a cross or, you know, Christian art, like a fish, you know, that's been around for, you know, 2000 years, but there are other symbols probably that, like a spiral or a circle, that, you know, have like this, like a circle for the sun or, you know, something like that, that has persisted for a long time. I always make the analogy with Egyptian art because that was something I was really interested in as a kid, that, you know, there are, you know, Egyptian art, when you look at it, you go, hey, that's Egyptian art. And it's been produced for, you know, several thousands and years. But then if you know Egyptian art, you can tell the difference between New Kingdom and Old Kingdom. And that's what I'm hoping we get to with Pecos River Style, because I think that we are going to be able to pull out some sub-styles from this. We're just not quite there yet. And lots of really nice comments. Anything else from the floor?
One last thing, and I don't want to dominate this, but the winged-anthropomorph that is at Faith Bell and the other site, there is almost identical, but not quite, classic members polychrome bowl that dates around 1075 to 1125, something like that. That has antlered anthropomorph with wings, and so my comment is, I think you talked about the persistence of some of these motifs. I think these legends and myths are so embedded that they're so maybe not so widespread, but they certainly endured through time in northern Mexico and the American Southwest. And what you're saying is, and I would be surprised if you didn't get different dates for those in the Lower Pecos.
Yeah, I think we have one site that is different, but I forgot to put that on there. But those two came back similar. So, but yeah, it's beautiful figure. So yeah. Thank you. I didn't know about you'll have to send me if you know where to find a picture.
I'll send you a picture of it. I'll send you a picture of it. Yeah.
That'd be great. Anything else? Well, it was wonderful to see all of you. Thank you for letting me talk about something that I care a lot about and passionate about. So thank you all. And have